This is section 11.7 on complex numbers. So this is part of the radical chapter on square roots and all that, but I save it for the quadratics because it's more appropriate. We actually apply complex numbers with quadratics. So back in section 11.1, we said that the square root of negative 16 is a non-real answer, and that's what your calculator says as well. The square root or any even root of a negative value is called an imaginary number, which our calculators aren't programmed for. These values are used in electrical engineering to help represent the flow of current. So you don't really need to know that part, but calling it an imaginary number sounds so strange, but they're actually positive and negative charges on electricity, and as they measure flow of electricity, they need square roots of negatives, and they call those imaginary numbers. So you can't see them per se, but they do exist in the electrical engineering world. So we use the letter I, a lowercase letter I, to represent an imaginary number. The lowercase letter I represents the square root of negative 1, and you'll need to remember that throughout this section. And I always just write it down on the top of my test. Again, once I'm in the testing center and you've sat down, you have your empty scratch paper, that's something to write down on the top of the test, just that you have it and you don't have to try to remember it. So if we have the square root of negative 16, we have 16 times negative 1. We know the square root of 16 is 4, and the square root of negative 1 is called I. So the square root of negative 16 is 4i. And that's true for any negative perfect square. We have square root of negative 9. We can break that down into the perfect square and negative 1. The square root of 9 is 3, and the square root of negative 1 is I, so 3i. Same idea with negative 25. That's 25 times negative 1. The square root of 25 is 5, and the square root of negative 1 is I. And you can do that for the rest of these pretty easily. It should be 8i, and that should be 9i. So you square root the positive number and represent the negative with the letter I. With non-perfect squares, we have to break down the radical just like we did in section 11.3. So we need to break this into 3 pieces: the perfect square, the factor it multiplies with, and negative 1. So your perfect square would be 25, the factor it multiplies with is 2, and then negative 1. The square root of 25 is 5, the square root of 2 stays the square root of 2, and the square root of negative 1 is I. So the order will be the perfect square, the imaginary number, and then the leftover radical. Remember, we always put radicals last. So that would be 5i radical 2. Same thing here, we're going to break it down into the perfect square, the number it multiplies with, and negative 1. So that would be 16 and 5 to multiply to 80, and then negative 1. The square root of 16 is 4, the square root of negative 1 is I, and the square root of 5 stays in the radical. So 4i radical 5. You can keep doing these on your own or just follow me. We have 100 multiplies with 2, then negative 1 goes by itself, square root of 100 is 10, square root of negative 1 is I, and then square root 2. So 10i radical 2. If you get to a number that does not have a perfect square, you just separate out the value and the negative, square root of 5 and square root of negative 1, so that'll be I radical 5. Radicals always go last. Here's another one. It seems like it has a perfect square in it, but it doesn't, so just do 10 and negative 1, and that'll be I radical 10. So if it has a perfect square, take it out. If it doesn't, just take out the negative. The product rule for square roots, you'll have to keep in mind that if I have the square root of -1 and I square it, the radical and the square kind of cancel out and we're left with -1. So another thing to kind of memorize or just remember is that I squared will always equal -1. And you always will make that switch. Anytime you see I squared, we'll change it over to -1. So let's look at some of these. The square root of -4 is 2i. The square root of -9 is 3i. 2i times 3i is just like variables, it's 6i squared. And as soon as we see I squared, we'll write -1, so that's 6 times -1 for a final answer of -6. Same idea here, this is 4i times 5i, that would be 20i squared, which becomes -20. Here we don't have perfect squares, so we're just going to have I radical 3 times I radical 5, just like we did up here. And so that's going to be I squared radical 15. And when I see I squared, I'll change that to a -1. So -1 times radical 15. Or you can just put negative radical 15. Same idea. Here's another one, 10. This will just become I radical 10. The square root of -4 is 2i. So it's going to be 2i squared radical 10, which will become -2 radical 10. So anytime I see I squared, I know I'll just change it to a negative. Similarly for the quotient rule, we know we can't have radicals on the denominator. We can break this down into 25, 5, and -1. So that will become 5i radical 5 divided by radical 5. Because there's a radical 5 on top and the bottom without any adding or subtracting, they can divide off for a final answer of 5i. There's a couple other ways to do that. You can use the quotient rule and put them together, and then you'll also get 5i. So it doesn't really matter which way you see it, as long as you're getting down to the same answer. For the next one, the square root of 81 is just 9. The square root of -6 will be I radical 6. We can't have I on the denominator or radicals on the denominator, so we're going to rationalize by multiplying the top and the bottom by I radical 6. So that's going to give us 9i radical 6 on top. I times I is I squared. And radical 6 times radical 6, remember from chapter 11, is just 6. When I see I squared, I'm going to make it a negative. So let me bring it down here. That would be 9i radical 6 over -6. And the 9 and the 6 on the outside can both divide by 3. So it'll be 3i radical 6 over 2 for our final answer. So just some basics of working with negative square roots. Let's look at some operations. So we have what are called complex numbers. Complex numbers contain a real value, an integer usually, and an imaginary value. Together, they create what's called a complex number. So it looks like this. We have a real number plus or minus an imaginary number. So you might have 2 plus 3i. That's considered one value. It's one complex number. Or you might have 4 minus 5i, and again, that's considered one complex number. So we're going to do some different operations with these complex numbers. Remember what we just talked about imaginary numbers. We're going to add and subtract, we'll multiply, and then we'll divide. So for adding and subtracting, you put the real number with the real number, the imaginary number with the imaginary number. So if I have 2 plus 3i, that's one complex number, added with negative 3 plus 2i, I put the 2 with the negative 3 to get negative 1, and I put the 3i with the 2i to get 5i, and together that's one imaginary number, complex number, sorry. Negative 1 plus 5i. On the next one, I'll distribute that negative. That'll give me 5i minus 2 plus I. You treat it just like variables. Then I can put the 5i with the plus I. It always wants the real number first and then the imaginary. So I'm going to put negative 2 plus 6i. And the next one, again, I'm going to distribute. So negative 3 minus 7i plus 6i. I can combine the two I terms, and it gives me negative 3 minus I. And you always put your real number and then your imaginary number. One more time. We'll distribute that subtraction. That's going to give us 8. I'm sorry, that should have been an I, not a 1. 8 minus I minus 2, and then that's going to become plus 3i. So the 8 can go with a negative 2 to get 6. The negative I can go with the positive 3i to get plus 2i. So you always put the real number first, then the imaginary, which seems a little backwards to us because when we see letters we think variables, but imaginary numbers always go second. So that's adding and subtracting, kind of like combining like terms. Let's look at multiplying. Keep in mind that I squared equals negative 1. So as we're multiplying, we multiply these just like variables, and then anytime we see I squared, we convert it into negative 1. So if I have negative 7i times 3i, it'll be negative 21i squared. When I see I squared, I'm going to make it negative 1 for a final answer of positive 21. So it always changes the sign of the term. 3i times 5i would be 15i squared, which would give us negative 15. So I squared just changes the sign. Here we'll do some distributing. This would be 3i times 2, which is 6i, and then 3i times negative I would be negative 3i squared. So that's going to be 6i minus 3 times negative 1, which will give us 6i plus 3. And we want to put the real number first and then the imaginary number. So in the homework it is particular about that. Real number first and then imaginary. And try the next one, distribute. It's going to give us 8i plus 18i squared. When I see I squared, I'm going to change it to negative 1, which creates 8i minus 18. But I'm going to write it with the real number first and then the imaginary number. So in my math lab, that's how it needs to be entered. So that's multiplying one term by two terms, distributing. Now we're going to multiply binomials, which is the FOIL technique. We're going to do 2 times 4, which is 8. 2 times I, which is 2i. Negative 5i times 4, negative 20i. Negative 5i times positive I would be negative 5i squared. So we can put the middle of two terms together. When I see I squared, I'm going to change it to negative 1. So that's 8 minus 18i. This is going to become plus 5 because the I squared makes a negative, which changes that. You can't see. The I squared becomes negative 1, which changes that subtraction to addition. And then I can put the 8 with the 5 for a final answer of 13 minus 18i. Real number and then imaginary. If you'd like to, go ahead and try the second one like that, just foiling. 2 times 1 is 2. 2 times 4i is 8i. I times 1 is just I. And I times 4i is 4i squared. So it's going to be 2 plus 9i. That's going to become minus 4. It's going to change the sign. So negative 2 plus 9i would be your final answer. Look at a few more of these. 2 minus I squared. So when the squared's on the outside, remember we have to write it twice. There are some shortcuts that you can do in your head, but in all my experience, students just mess them up, and I don't want you to be frustrated. So just write it twice and multiply it out. Students are much better seeing everything that they're multiplying. So we have 4 minus 2i minus 2i again plus I squared, which is going to give us 4 minus 4i. That's going to become minus 1. So the 4 up front will go with the minus 1 in the back. So it'll be 3 minus 4i. If you'd like to pause and try the second one on your own, you're more than welcome to. I'm going to write it out twice. 3 plus 2i times 3 plus 2i. 3 times 3 is 9. 3 times 2i is 6i. 2i times 3 is another 6i. And 2i times 2i is 4i squared. So from there, the 6 i's combine. I'm going to change I squared to negative 1, so it becomes 9 plus 12i minus 4. The 9 and the minus 4 can combine to 5 plus 12i. The last couple are a little more complicated here. We're going to FOIL. 7 times 7 is 49. 7 times negative 3i is negative 21i. 3i times 7 is positive 21i. And positive 3i times negative 3i is negative 9i squared. The two middle terms zero out for this one, so we get 49. This is going to become plus 9 because of the I squared. And 49 plus 9 is no more imaginary numbers, you just get an answer 58. And last but not least, this one's tricky with the radicals. So we have radical 3 times radical 3, which remember is just 3. Radical 3 times 2i is going to be 2i radical 3. And then again, negative 2i times radical 3 is going to be minus 2i radical 3. Negative 2i times positive 2i is negative 4i squared. So those middle ugly terms zero out. We end up with 3. This is going to become plus 4 for a final simplified answer of just 7. So adding and subtracting is like combining like terms. Multiplying, really just have to remember that I squared is negative 1. Everything else is just like variables. And finally we have dividing. So dividing, we're going to multiply by what they call the complex conjugate of the denominator. And we saw conjugates earlier, so it's the same idea, it's just called a complex conjugate because of the imaginary number. So we're going to multiply the top and bottom by 2 minus 3i. This is the same thing as rationalizing the denominator, which I believe was section 11.5. So it's just like rationalizing the denominator. So we're going to do 6 times 2, which is 12. 6 times negative 3i is negative 18i. And then on the bottom, because they're conjugates, and I colored pencil real quick. because one is plus and one is minus, the middle terms are going to zero out. So you can just do first and last, which is the same thing we talked about in section 11.5. So that's going to be 4 minus 9i squared. So the top stays 12 minus 18i. The bottom becomes 4 plus 9. For a final answer of 12 minus 18i over 13. Now I'm okay with that answer, but in my math lab they're going to separate it into 12 over 13 for the real number minus 18 over 13i for the imaginary number. So it's just separating the denominator into the real part and the imaginary part. If you'd like to pause the video and try the next one, it's very similar. We're going to multiply the top by 1 plus I and the bottom by 1 plus I. Again, because they're conjugates, one's minus and one's plus, the middle terms are going to zero out. So we'll distribute the 5. That gives us 5 plus 5i. On the denominator, we can just do first and last. So that's 1 minus I squared. So that's 5 plus 5i. That's going to become 1 plus 1. So 5 plus 5i over 2. And we'll write it as two separate pieces, 5 over 2 plus 5 over 2i. So I'm not doing anything, I'm just writing them separately. Same idea for the last couple. We're going to multiply the top and the bottom by the conjugate of the denominator. Remember, it's about the denominator, not the numerator. So 4 plus 3i, 4 plus 3i. On top, we're going to have to multiply it out using FOIL. So 3 times 4 is 12. 3 times 3i is 9i. 2i times 4 is 8i. And 2i times 3i is 6i squared. We'll clean that up in a minute. On the bottom, because they're conjugates, we can just do first and last. That's 16 minus 9i squared. So on top, I'm going to combine the middle two terms. I'm also going to work with the I squared. So it becomes 12 plus 17i minus 6. And this becomes 16 plus 9. On top, I can combine the 12 and the negative 6. It's going to give me 6 plus 17i. 16 plus 9 is 25, so I'm going to put this one over 25 and that one over 25. And they like to have the I kind of by itself. Like the 17 over 25 is the coefficient, and then I is after that. I encourage you to pause the video, try this last one on your own. So we're going to multiply the top and the bottom by the conjugate of the bottom. We're going to have to FOIL the top. 2 times 1 is 2. 2 times I. 1 times I. And I times I. And then on the bottom, because they're conjugates, I can just do first and last. I'm going to put these together and take care of that. So that's 2 plus 3i minus 1. And that's going to become 1 plus 1. Which gives us the 2 and the negative 1 can come together. 1 plus 3i. And 1 plus 1 is 2, so this will be over 2, and that'll be over 2. So it's 1/2 plus 3/2, and then I. That's just how you enter it in my math lab. For me, it's all the same thing, but that's how you enter it correctly. Alright, and that is working with imaginary numbers and complex numbers.